recording. Here we're going to do another solving trig equation example, and this is very similar to the example we did previously where it was asking us to solve sine theta plus 1 equals cosine theta. This example gave us a hint in the directions to square and convert to quadratic type. So we ended up squaring both sides of this equation. And when we did square both sides of this equation, we wound up with sine theta plus 1 times another, we had to write it twice, sine theta plus 1, we FOILed, first, outer, inner, and last. And then we got sine squared plus 2 sine theta plus 1 equals cosine squared. If sine and cosine were on the same side and we squared it, we would end up with an expression that had sine and cosine together, and that's a little troublesome. So I am going to rearrange this a tiny bit, and then we're going to square both sides. But then when we finish this problem, I'm going to show you what would happen if we squared both sides without rearranging it first, and why we have to do that step. So I want to subtract one of these to the other side. I don't care which one you want to subtract. Anybody have a preference? Would you rather subtract secant theta from both sides or tangent theta from both sides?
Tangent.
Tangent, sure. So if I subtract tangent theta from both sides, minus tan theta, remember we don't just pick things up and put them down. Can you just read off what would the next line be, Kiara?
It's going to be secant theta equals 1 minus tan theta.
Right. Now, even if it was secant plus tan, secant minus tan, whatever it is, you could leave it as a subtraction problem or addition problem. You don't always combine. You only combine things if they're like terms. So if they're both secant, both cosine, whatever. Now, this is where I want to square both sides. Okay, I want to square the left of the equation and the right of the equation. But you don't just square each piece. Like you get a little exponent 2 and you get a little exponent 2 and you get one. That's not how squaring works. You square it as a quantity, and squaring something means it's so nice we write it twice. So you might have to multiply it twice by writing it out twice. So do you have a question or do you want to say the next step, Jeremiah?
I had a question, but then I answered it myself.
Okay, what was it in case somebody else is thinking it maybe?
I was gonna ask, why can't we just change the secant to 1 plus tangent squared?
Okay, good question. So think about what Jeremiah just asked. That was good. He wanted to know, well, why don't we just change secant theta into 1 plus tangent squared? And then he realized his own answer. So what was the answer to your question?
Well, because the secant isn't squared.
Exactly. So I'm going to write secant theta equals 1 plus tangent squared, question mark. Nope. Right? Secant squared theta does. And that's why we're squaring both sides, so we can get those squares involved. Now, next step. We are going to now square the left, and we're going to square the right. What do I write down for the next step if I square the left side and the right side? What do I get for the next step if I square the left side and the right side? Anybody? You get secant squared theta. That's pretty straightforward for that one. And then here, I want you to picture it as 1 minus tan theta times another 1 minus tan theta. And like I just reminded us, we're going to FOIL or expand, multiply this fully out. So in the next line, what should I write down? Go ahead, Emerson.
Would it be 1 minus tan theta?
Okay. I'm not going to write it yet because you're going to combine like terms. So tan theta is outer. What's inner?
And then the same thing.
So we'll have 2.
Yeah. And then it would be positive tan squared theta.
Good. Perfect. So on the right, when we squared it, we got that. On the left, I'm just going to rewrite this so I have it a little bit more lined up. I have this. Now, let's kind of box off. What Jeremiah was thinking before is actually a good idea now. I have a tangent and I have tangent squared. So that's kind of the majority right now. Like they're kind of taking over this whole equation, tangent, because I have it to the second and to the first. Secant squared, well, maybe we got to swap that out. So what could I write in the next line to replace secant squared so that I have one equation with one trig in it the whole way across? You have 3 more minutes to get your participation for the day in. What am I going to replace? I just said we're going to look at what Jeremiah mentioned. So what do I write on the left?
Not
Plus tan squared. Oh, sorry.
Yeah, go ahead. Whoever was going, either one of you.
Sorry,
I was just gonna say something with tan, but
Yeah, it's on the screen. It's already there. It's written. Do you see it?
the whole thing or just the 1 plus tan squared?
Well, if that's what secant, so Jeremiah asked, secant theta equals 1 plus tan squared. And then he's corrected himself. He's like, no, secant squared does. So what are we going to write in place of secant squared then?
Secant equals 1 plus tan
No, well,
squared?
what does, we just said secant squared does. Does what? Does equal this. So this,
Oh, so then just 1 plus tan.
right. Do you see that now?
Yeah.
Okay. So 1 plus tan squared theta equals 1 minus 2 tan theta plus tan squared theta.
Can the tans cancel out?
If we have 1 on both sides, the reason they cancel out is if you were trying to combine like terms or organize everything and you subtracted it, you would get none of them. So yes, in this case it would. All right. Then what else could I do from here? I have 1 equals 1 minus 2 tan theta.
Could you add the 10? Sorry, add 1.
Add 1.
Subtract 1 from the.
We could
yeah.
subtract 1. That would be a little bit better. Yeah. So if I subtract 1, I'm just going to kind of go over here. 1 equals 1 minus 2 tan theta. Okay. Minus 1 from both sides. Okay. 0 equals negative 2 tan theta. Now it ended up not even being a quadratic type because everything kind of cleaned up. All right. What can we do next, Sam?
Oh, my hand was up from the last question. I was going to say add 1.
No, well, it wasn't add 1. We fixed it anyway.
Here you could divide by negative 2.
Okay, divide by negative 2. All right, from here, what do I get for the next line? Try raising your hand so I could track who is participating, guys, because we're got 30 seconds to finish this problem. Otherwise you don't get your participation, I guess. 0 equals tan theta, and we ask ourselves the tan of what angle or angles equals 0. So think of tan, the meditating man. What angles does tangent equal 0? Think of tan, the meditating man. He's got his hands in the little meditation circles at the sides. What angles does tan equal 0? Go ahead, Jeremiah. Or Jispel or Lispel. I saw hands up. Go ahead.
0 and pi.
Yeah, 0, pi, ... So part A, between 0 and 2 pi, we only include normally, just so we're clear on this, it's like this in our directions. We don't include 2 pi. That's part A. Part B, I want every answer that lands at 0, at pi, at 2 pi, at 3 pi, at 4 pi. What we could really write as a shortcut is theta equals n pi, comma, n is an element in the set of integers. You could put plus 2 pi n for both of them, but because of the way it hits boom, 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 boom every pi, then we can kind of consolidate it into just this one equation where we could just say 0 plus pi n because it's pi apart over and over and over again. I do go into a lot of detail explaining that in another example. All right. So this was solving using part A between 0 and 2 pi, where we include 0 and not 2 pi. And part B, finding all your solutions. So using your answer to part A and taking it one step further. Okay, so hopefully that helps. Hopefully you understand how to do this example. I'm going to ask you to do, for homework, you're going to do numbers 20, 21, 22, 23. 20, 21, 22, and 23 for homework. And then you're going to have some classwork, and we're going to grade the classwork too. Maybe I'll put you in with a partner or something like that. But I hope this was helpful. If this helped and you understand this example, if you're watching, thumbs up. If you don't understand or you want more like this, give it a thumbs down, okay? Have a nice day.